Hey, it's Troy. So it's been a while since the last video on porting BASIC to your 6502. So I thought it was time I revisit it and add some custom graphics commands for my TMS9918. First, I'll look at using the EhBASIC call command to call assembly routines, then look at supporting command arguments before modifying the EhBASIC source code to add in some custom command keywords for these subroutines. So before we get into it, I'd just like to say that all of the code that you see in this video, you can actually try yourself in my emulator, which is available online. So if we just go to the GitHub page and scroll down to HBC56 emulator online, click on that, and here it is. And so you can try out all the programs as they come up. Also, instead of typing them out by hand, if they're in a text file, you can just drag them in, and that just emulates key presses. And run. So there you go. So hope you follow along, and let's get into it. First up, we'll take a look at the fantastic EhBASIC language reference on Hans Otten's retro computing site. Here we'll see all of the commands in EhBASIC. So what we're interested in today is the call command. So the call is intended to call a native subroutine, which you can write in assembly, and is designed to take in no arguments and return no values either. But as we'll see shortly, that's not strictly true. We can pass it arguments, which we'll take advantage of. Okay, so let's start out by just taking a look at basic call command in the emulator. So bring up my HBC56 emulator here with basic. And so we just want to try the call command. So we just need a subroutine that we can call. I'll just pause the emulator and have a look at the source code. So in my TMS9918 library, I have some subroutines, and one of them clears the screen. So we'll try that. TMS console CLS. So here, if I hover over it, I can see the address there, E8, E1. So if I just resume the emulator, so cool, E8, E1, clears the screen. Perfect. So that's not very user-friendly, and also any changes I make to the kernel or to BASIC, that address will change. So next up, we'll look at a strategy to keep the address consistent between updates, creating a function table or a jump table for these subroutines you might want to use. Back in VS Code, and you can see here we have this, I've created this jump table ASM file, which is currently empty. So what we can do is pick an address that we want to put this jump table at, and that will remain fixed. So the way I do that in Acme Assembler is to asterisk equals, and we'll make it say C000. So all of my jump table addresses will start from there. And then we just create a label. So the label is sort of optional. Now we just want to do jump TMS console CLS. This C000 is like an alias to TMS console CLS. Let's try that. So we'll go to basic TMS, start the emulator. So now here I should be able to just call C000, exactly the same thing. With the benefit of any changes I make, that value will stay the same. So another thing I could do is assign that address to a label. So I could CLS equals C000, and then I could go call CLS. Still not super user-friendly, but we'll have a look at that later in the video. So next up, we'll try and add arguments. So let's try and change the color. Back on this site, you can see there's a page on extending the call function. So this gives instructions on which EhBASIC subroutines to call in order to parse a line, and in this case we want to look for the next value after the comma in call to get a color value to pass to our color subroutine. So let's go and create this subroutine to read an argument and set the color. This basic functions file, which is empty, where I can create this subroutine. I'll just call it basic color because it's only for basic. We want to grab that argument, JSR CEB. So my TMS subroutine, which changes the color, needs that argument in the accumulator, where this subroutine here places it in the X register. So we need to transfer it. And then we can just call or jump to my TMS init color table, that one right there. So next I need to add an entry to the jump table so we know which address to jump to. So if we go into here and we'll call it color jump basic color. Okay, and so let's try that. Okay, so let's see if that works. Awesome. And okay, we'll type out a program to cycle through the colors and print out a color value. That's great. All right, so next up we'll look at adding custom commands to BASIC to do similar things. First we'll step into the EhBASIC source code. So the first thing we'll do is set up the tokens. So that's basically a list of token values which we'll need to assign to these commands. So we'll just go through and add these in. Anywhere will do. So next we'll go and set up the LBB entries. So that's basically a map grouped by the first letter of the command. So I'll just search for an existing one here. So I'm looking for the ones that start with C, and we want to put those in an alphabetical order. So I'll put CLS here, and color right after it. So next we need to set up the keyword definition. So we'll just search for the closest one here, bit clear. We want LBB bit clear. And we need to put ours immediately after that. So add 2, CLR and color. So the first here is the length, starts with C. And color, so that's 5 letters, starts with C also. Color. So then lastly we need to define the function or the subroutine to call when this command is hit. So here we put in the addresses of our subroutines we want to call. Whoops. So CLS and color. Now what do we call them? Okay, so that's about it for that. Let's try it out. CLS works, that's great. So that's an error because we're expecting a comma. Right, so here we're scanning for a comma and getting the byte. We don't want to do that. Instead, we just want to get the next byte argument without the comma. So we need to use this subroutine instead. Let's try that. Perfect. Awesome. All right. So let's go and extend this a bit further and add some display routines. So for that, I'm going to put the TMS into graphics 2 mode, which is sometimes known as bitmap mode. So I need a command to do that. And then I'm going to need a plot command and possibly an unplot command as well. First thing I'll do is go to the basic functions file, and I'll want to create a subroutine to set the display mode. That'll take a single argument, which will be the display mode. Now I think that should be 0 for text mode, 1 for graphics 1, and 2 for graphics 2, or bitmap mode. I'll start off with a function table for those 3 modes. So I already have in my TMS library, I already have subroutines to set those modes. So I'll create the table, mode table, and that will just consist of the 3 subroutine addresses. So TMS mode text, mode graphics 1, and TMS mode bitmap. Okay, so now I can create a small subroutine to call the correct TMS mode subroutine depending on the X register. So we'll do that like this. So that will jump to one of those functions depending on the X register 0, 1, or 2. And that's a 65C02 instruction. So next up, we need the subroutine to call from BASIC, which will take in the argument and call the correct mode. So I'll call that BASIC display. So like the color subroutine, I want to grab a byte argument. So that was JSR lab GTBY. Now that's in the X register. What I need to do is double that. Actually, first I'll need to validate that it's between 0 and 3. So compare to, 0 and 2, compared to 3. So if it is greater, I'll add a error routine. If not, let's double it, transfer to the X register, and call do mode. So this is taken from the documentation I found on that website earlier. Now I need to go and modify the basic source to add that as a command. But before that, I think I might as well go and add the subroutine for plot as well in basic plot. So here I want to take in 2 arguments. So if I take a look at the basic source code and search for another function which takes in 2 arguments. So I think poke's probably a good example. Let's search for that. Okay, so we've got this one here, GADB. So byte argument is in the X register, and the address is in item PL. So that's the first argument. So if I switch back. Okay, so that gets our 2 arguments. The second argument will be in the X register, so that's our Y. So we'll store that in memory. First argument will be in the item PL, so let's load that. Now my plotting subroutine in my TMS library requires the X position in the X register and the Y position in the Y register. So let's just do that. Okay, so now I have some subroutines to help out with this. So set. Okay, so this sets the pattern temporary address for mode 2 based on the X and Y registers. Now what we want to do first, we want to read from that location. because we need to know the value that's there so we can modify it and add in the pixel. That gets the byte. We'll also want to get the lower 3 bits of our X position, because that will be the bit position within that byte. And it with 07. Transfer that to the X register. We still need to load that byte from the TMS, from the VRAM. Okay, so now we've got the byte that's already in VRAM in the A register. We've got the position of the pixel we want to set in the X register. So I have these lookup tables already to help with stuff like this. So what I want to do, I'll just find... So here in tables.asm, so I've got various lookup tables for passing in a value and getting the bit position either from the left or the right or the inverse of that. So in this case, we want the table, we want the bit from the left. So this one, and we want to OR that with what's in our accumulator. So, and we'll just push that onto the stack for now. So now we want to set the TMS into write mode. So this function here stores that address in a temporary in the TMS library. So set address read and set address write will use that temporary, so it knows the location already that it wants to read and write to. And then all we need to do is pull our value back again and write it. So just put TMS put. Okay, so next up we'll need to do similar for the color. So there are 2 tables. We've got the name table and also the color table. So let's get these values back again. So similar to the name table functions, I've got... So that uses the X and Y register to set the correct location address in the TMS VRAM. Now we want to write to that address, so we need to call a subroutine for that. Load the color and output. Okay, that looks good. I think we do also want to pause interrupts during all this. So push the flags and disable interrupts. And then here we can re-enable them again. And the reason we do that is because my interrupt handler has automatic code for the console, which includes the flashing cursor and whatnot. So we don't want to be doing any of that while we're working with the TMS. So now I'll go and add basic handlers for these and we'll try it out. Okay, so I'll just type out a test program for this. I'll just draw some lines in each color. Awesome. So let's try something a bit more advanced. We'll draw some circles using the midpoint circle algorithm. Fantastic. All right, and as always, we have to try this on the real machine too.